The second method that you can use to simplify radicals is called the pair method. And so this one might be a little bit easier if you don't really recognize which perfect squares are in a number. And this one kind of breaks it down a little bit further. So there are going to be 4 basic steps to do this method. First, you're going to break the radicand into prime factors. Step 2, you're going to group pairs of the same number. Step 3 is simplify. And then step 4, you're going to multiply any numbers in front of the radical and multiply any numbers inside the radical. So let's go through some examples with this one. So the first step is to break this into prime factors. So I'm just looking to break this until I can't divide anymore, except for by 1. So I like to go ahead and first start with 2, and I know I can divide 2 into 32 because 32 is an even number. And so I know that 2 times 16 gets me 32. And again, you can just do 32 divided by 2 to find out what this number is. So now I can't break up 2 anymore because that's a prime number. That means that only 1 times 2 gets me 2. But I can break up 16 further. And again, I'm just going to divide it by 2. And that's going to be 2 times 8. 8 can be broken into 2 times 4. And then 4 can be broken into 2 times 2. So now my second step is I'm going to pair these numbers together. And so I see that I have a pair of 2's. I have another pair of 2's. But then my last number I'm left with is just 1, 2. And so the trick here is that I can, for each pair, I can only take out one of that number. So I have a pair of 2's here, so that means that I can take out 1, 2 in the front of my radical. I have a second pair of 2's, so I can take out 1, 2 in front of my radical. The numbers that didn't get a pair, so here my 2 did not get a pair, that's going to stay underneath my radical. And then my last step here is I just need to multiply these 2 numbers out in front. So 2 times 2, I get 4 square root of 2. And so the reason why we're only taking out 1 pair is because my 32 here can really be written as 2 times 2 times 2 times 2 times 2. I had 5 2's. And with these pairs, that means this is really the same thing as the square root of 4 times the square root of 4 times the square root of 2, which square root of 4 is 2. And so we see we're back where we started. So that's why for each pair, you only take 1 out in front. Okay, so let's look at the next one. So here I have the square root of 175. So here I see this is an odd number, so that means that 2 can't divide evenly into it. But I see that it ends with a 5. I know that any numbers that end with 0 or 5 can divide into it evenly. So I can take 5 and then 175 divided by 5, I get 35. And since 35 ends with a 5, I know that 5 can divide into that as well. So I have 5, and 5 times 7 gets me 35. Now 5 I can't break up anymore because only numbers that multiply to 5 are just 1 and 5. And then same with 7. The only numbers that multiply 7 are 1 and 7. So these are both prime factors. So this one I'm actually done here. So now I need to look at where my pairs are. And so I'm looking at the ones that are at the bottom of this factor tree. And so I see that I have 1 pair of 5's. So that means since I have 1 pair of 5's, 1 5 comes out. And then all that's left inside the radical is this 7, since it did not have a pair. And so that will become my answer. So now for number 3, this one looks a little bit different. We notice there's a 6 out in front of our radical. That's okay. That just means at the very end, we're going to be multiplying those numbers out in the front. So like what we had up here, this 2 and times 2, there'd be a 6 here as well. So I just multiply all of those out in the front. So I'm going to go ahead and first go and break this up. So I see this ends with a 5, so I know that 5 goes in there. And if I take 125 divided by 5, I get 25. And then I know that 25, that can be broken up into 5 times 5. So now when I'm finding my pairs, I see I have 3 5s here, so that means I have 1 pair of 5s. And so since I only have 1 pair of 5s, that means that 1 5 gets to come out. But again, I can't forget about this 6. So 6 is going to be there first, then times 5. And now I need to see what I did not use. And I see I didn't use 1 5 here. So that 5 is going to remain under the radical. And then when I do 6 times 5, I get 30. So you could have actually stopped here. You could have recognized that 25 was a perfect square. And so you could have recognized that 6 square root of 125 is equal to 6 times square root of 25 times 5. And then you would have ended up with the same answer. Okay, go ahead and pause the video. I want you to try and do number 4 on your own. When you think you have it, go ahead and press play. So the answer you should have gotten here was negative 64 times the square root of 5. You could have broken up this first pairing a lot of different ways, but at the end you should have seen that you got 3 pairs of 2s. So that means that 3 2s came out with that negative 8, and then you should have been left with a 5 here at the end. So all these ended up being that there's only one number at the end. That won't always happen. Sometimes there may be more. So let's say that there was actually an extra 2 here. So let's say there was like, I don't know, another 2. That would mean I would need to multiply these 2 together. And so my answer would have instead had negative 64 times 5 times the square root of 2. Negative 64 times the square root of 10. So be on the lookout for that. That can also happen.